All right, let's talk about Starling forces. So as you can see, this is just the normal capillary, and the outside would be the interstitial fluid, where interstitial fluid would exist, which is the interstitial space, and there's a fluid, blood containing the fluid, flowing this way, and we have something which is called hydrostatic pressure. Let's give it a number, 35, and all the numbers that I'm going to be giving out, they're going to be in millimeter Hg. So this is the pressure that is trying to get rid of the water, pushing water outside the capillary. So what that means is we have 35 trying to push the water, trying to squeeze the water outside. On the other hand, we have proteins, we have red blood cell, we have white blood cells. We have a lot of things that are trying to keep the water inside, and those are called onconic pressure. Let's change the color. OP, let's give it 25. So we have 35 trying to get rid of the water and 25 trying to keep the water and not let the water to go outside. It's just like a sponge trying to keep the water. But also, on the other hand, we're trying to push the sponge by creating the pressure that has been created by your heart, that is trying to push the water and nutrients outside the capillary and going to the interstitial. Also, in this space here, we've got the same pressures, but a little bit different. So on this side is -5. Why -5? Because it's just a number showing that this 5 is actually helping to gain water from capillary. So the minus is adding up to the other side. So it would be like if you don't consider the OP 25, it would be 40. And also we have another number, which is we have the same thing on this side. OP on this side is 10. This is the onconic pressure or osmotic pressure on this side, which is also trying to get the water to this side. So HP actually is helping out the HP inside the cell. And when we add everything together, we get 35 plus 5 plus 10. Oh, no. Plus 10, and we get 50. And this is how much your body trying to push the water outside your capillaries. On the other hand, there is this number 25, which is trying to keep the water inside the capillary. So we get 50 minus 25, we get 25 mmHg, trying to keep the water. This one is the negative hydrostatic pressure, which is technically helping out your